to investigate the relationship between charge and capacitance whilst keeping the current constant. 1. Close the switch and constantly adjust potentiometer or variable resistor to keep the charging current constant for as long as possible. This will be more difficult as the capacitor is nearly fully charged. 2. Record the potential difference at regular time intervals until it equals the potential difference of the battery. 3. Plot a graph of mean potential difference against time. Charging capacitor graphs. The gradient of a charge time graph gives the current. The area under a current time graph gives the charge. Capacitors and energy. When the switch is flicked to the left, the capacitor charges. One plate becomes positive and the other becomes negative. Because like charges repel, the charges on that plate are being forced together against their will. This requires energy which is supplied by the battery and is stored as electric potential energy only for as long as the charges are held. When the charges are released, the electric potential energy is zero. The electric potential energy is equal to the work done in moving the extra charge into the plates against the potential difference across the plates. By plotting a graph of charge against potential difference and using the area to find energy, it can be seen that the work done by the source increases as the charge in the capacitor increases. Half of the energy is lost to resistance. This gives the equations. W equals 1/2 QV. W equals 1/2 CV caret 2. W equals 1/2 Q caret 2/C. A buildup of charge results in a buildup of energy. Discharging a capacitor. To discharge a capacitor, remove the power supply and close the switch. The discharging current flows in the opposite direction to the charging current. This is because once the power supply is turned off, the capacitors become the only source of electrons. Electrons are attracted to the positively charged plate, but there is an insulator between the two plates, so the only way for the electrons to travel is in the opposite direction. The capacitor is fully discharged when the potential difference across the plates is zero and the ammeter reading is zero.